right, so Networks Day 1, this is a supplement that is not in your book but will be on the EOC. And so the essential question is, how do you decide if a network is traceable or not? So pause throughout the notes as you need to in order to write down the essential information. All right, so first main idea is vocabulary. And so we've got a few vocabulary words. So network is the first one. And a network is a picture with points, segments, and or curves. And when I'm done with all the vocabulary, then I'll kind of draw an example that'll encompass all of them. Okay, nodes is the next vocabulary term. And this is the points of the network. So however many points or dots that you have in your network, we call those nodes. Edges. Edges are going to be the segments or curves that you have in your network. Those are the edges of the network. And then a circuit is a path that starts and ends at the same point. So for instance, I guess we'll make that a no. Okay, so this is an example of a network. I have nodes, so points A, B, C, A, B, O, and D. Those are the nodes of this network. And then this curved piece and all of these segments are what we call the edges of the network. Now, a circuit, let me change colors here. Not working. Let's change to purple. So a circuit means that I start and end at the same point. And so if I started here at D and then I went along this edge and then came back to D, that created a circuit. It means you started and ended at the same point. Now my circuit could have been that small, or I could have gone from the D to the A, down to B, down to O, and then back to D. That would also be another circuit in this network. So the points A, B, O, and D, those are the nodes of the network. The curved part and then the segments are what we call the edges of the network. And then if I need to create a circuit, or I don't want to create a circuit one way or the other, a circuit would be if you start at one place and then go along some edges until you get back to that same node that you started. Okay, so that's our vocabulary. Oops, darn it. And then degree of a node. The degree of a node is going to be the number of edges connected to the node. Try and erase this, and then we'll actually do an example that helps you with this. Just want to make sure that you get the vocab down. So the degree of a node is the number of edges connected to the node. All right, so we are going to, you need to have the substitute pass out the example 1 that you will glue into your skinny column here. So pause as you need to. Okay, so now let's go over this. So I've just enlarged the picture a little bit, but this is a network, and this is a network that shows highway distances in miles among cities. And so these numbers represent the miles between these different cities. Okay, and so it doesn't mean that there's a straight line distance. You know, sometimes highways curve and all that kind of stuff. This edge just represents that the highway between them represents 36 miles. Okay, and so part A, we want to find 3 different paths from Riverside to Salem. And so I need to start with Riverside, and I'm just going to use the first capital letter of each one, and then you make a directional arrow. So I start at Riverside. One way I could go to get to Salem is I could go Riverside, Centerville, Georgetown, and then up to Salem. So I would do R to Centerville to Georgetown to Salem. So that would be one path. So then pause for a moment and see if you can come up with 2 more paths to get from Riverside to Salem. All right, so a couple more that I came up with. I went from Riverside to Fairview to Oak Grove to Salem. Then you could do a long route. You could do Riverside to Centerville to Mount Pleasant to Georgetown and then up to Salem. So yikes. So that as long as what you do is going along those highways. So if there's not a highway between Riverside and Oak Grove because they don't have a line connecting them, you can't go that way. You would have to go around and follow the edges. Okay, part B. Now we want to find a path from Mount Pleasant to Salem that includes every city. So you have to hit every city. Okay, so take a moment, pause, and see if you can come up with that one. All right, so I went from Mount Pleasant to Georgetown, to Centerville, Riverside, Fairview, Oak Grove, and then Salem. So it didn't say you had to go over every highway, it just said you had to make sure that you hit every city and you ended at Salem. So start at Mount Pleasant and end at Salem. Okay? And then part C says find the shortest path from Fairview to Georgetown. So this is where the numbers now come in handy. So we need to find the shortest path. So pause for a moment and see if you can find a path to where that path is going to be the least amount of miles. That's what it's talking about for your shortest path. So go ahead and pause. All right, so the shortest path will be from Fairview to Oak Grove to Salem to Georgetown. And when you give me shortest paths, I want you to give me the number that goes with it. And so that is the shortest path was 61 miles. So on your homework, when I ask you for the shortest path, make sure that you give me the path and the number that goes with it. What was the shortest one? Okay. All right, example 2. Go ahead and pause. I don't have one for you to paste in because this is a fairly easy picture to draw and write the directions. So go ahead and pause and do example 2 in your notes. Okay, so example 2 talks about find the degree of the nodes in the given network. And the definition of degree was how many edges are touching that node. So for instance, for P, the degree of P has 1, 2, 3 edges coming into it, so the degree is 3, and then it says tell if it's even or odd. Well, the number 3 is odd. Okay, and then for instance, point S or node S, it's got 1, 2 edges coming into it, and so that is a degree of 2, and the number 2 is even. So now try and see if you can do the last 4 points. So pause for a moment and do that. All right, so W should have 1, 2, 3, 4, because each of these, this one right here does not count as 1. This is an edge and this is an edge. 2 separate ones, so this is even. V should have been 1, 2, 3, which is odd. R should have been 1, 2, which is even. And then Q, 1, 2, 3, 4, which is even. So finding the degree of a node is going to help us with something here in a second in our notes. So that's how you find the degree of a node. Okay, now leave 6 to 8 spaces for questions, answering questions and such. And then our last section of main idea today is traceable networks. So traceable network is the main idea. And a traceable network is a network that can trace over all of the edges without lifting your pencil. So you may have done these at some point as like a little brain teaser, where they give you a network or they give you a picture. You didn't maybe know it was a network at the time. They gave you a network, and then you had to see if you could trace over all the edges without picking up your pencil. So that's a traceable network. Now, if you have a really complicated picture, it may be hard to decide if it's traceable by actually trying to find a traceable path and tracing over the thing. So there are two different ways that you can identify if a network is traceable without actually taking your pencil and tracing it over the segments. Okay, so a network is traceable if one of two things. Either all the nodes have even degrees. So if every node has an even degree, then your network will be traceable. Or if the network has exactly 2 odd degree nodes, so it has 2 odd degrees and the rest are even, that is a sign that it will be a traceable network. So if you need to pause, you can, so that you can copy those down, then we'll do an example. Okay, so go ahead and have the sub pass out example 3 so that you can paste it into your notes. All right, so example 3. So it says, decide if the following networks are traceable, explain your reasoning. So since you have to explain your reason can't just be, oh, because I traced a path and touched every edge. You have to actually use one of either you're saying because it's traceable because all the nodes are even, or it's traceable because there's exactly 2 odd nodes. Okay, so what I'm going to do is go through, I've got 1, 2, 3, 4, so that's even, 2, that's even, 2 even, 2 even, 2 even. So this is traceable, so yes. And you would say something like, because all even nodes. Okay? Part B. Let's go through and figure out even or odd. So this is odd. 1, 2, 3, 4, 5, odd. 1, 2, 3, odd. 2, even. 1, 2, 3, 4, even. 1, 2, 3, this is odd. Now, is this traceable or not? This would be not, because they're not all even, and there's more than 2 odds. So you would say no, more than 2 odd nodes. Because you have to have exactly 2. Now, if I would have just had 1 odd node, that would not work either. You have to have exactly 2 odd nodes for it to be traceable. So then this was a no because there were too many odds. There was more than 2 odd nodes. Okay, it's easy as that. That's how you decide without actually tracing over it. All right, so copy this example 4. This is our last example for today. So copy that in there, and then we'll work it out. So you can pause as you copy. Okay, so for example 4, you've got a lot of choices. So if I gave you something like this on a quiz or a test, first I'm checking that you have 4 dots for the nodes. And then you need 6 edges. So if I go all the way around like this, 1, 2, 3, 4, and then I could do 5 and 6. Now where these 2 edges intersect, that does not create a new node in network world. It would create a new point for us in regular geometry world, but it would not in network world. So that would be 6 edges and 4 nodes. Okay. Another one you could have done is you could have done this type of thing, but then go like this, which works too. 1, 2, 3, 4, 5, 6 edges and 4 nodes. Okay? And you could have had lots of other different choices, but as long as you have 4 points and then you have your 6 sides. Okay, now part B, is your network traceable? Explain your reasoning. Is this one traceable as I have it drawn here? This one is no, too many odd nodes or more than 2 odd nodes. Because these are all 4 odd. This one has odd, odd. Oh, you know what? This one wouldn't work. Nope, because that would make another one up there. So that one doesn't work. So then you would, if you had your own, then you would have to decide if it was traceable or not. Either they're all even